Welcome back, our dear learners, and thanks for following our lessons. Kalanda Eden Matovu are my names. We are going through pure. The topic is trigonometry. Previously, in our lesson 7, we proved some trigonometric identities, where we discovered that if you have cos squared theta plus sine squared theta, this one is equal to 1. Then we can have 1 plus tan squared theta, this one is sec squared theta, and also we can have cot squared theta plus 1 is equal to cosec squared theta. Now, with those two identities, so with those three identities, we call them the trigonometric identities. We discovered that we can use them to solve trig problems. We can also use them to prove other identities, but using these ones as you're seeing them. For example, we have a question there. We have sine theta over 1 plus cos theta, then 1 plus cos theta over 1 plus sine theta. This one is equal to, now if I consider the left hand side, remember I said when it is a proof, we can prove either sides. In other words, you can prove that the elements on the left hand are equal to the elements on the right hand, or vice versa. So, the LCM here, we do have our LCM as 1 plus cos theta into sine theta. That is our LCM. So if that is our LCM, 1 plus cos theta goes here, sine theta times. So when you multiply with that element in the numerator, we end up with sine squared theta plus, now we have this with this, that one is 1 plus cos theta, everything squared, which gives us sine squared theta plus, now when we expand this, what do we get? That's what we want to look at and see. We do have 1 plus 2 cos theta, then plus cos squared theta all over 1 plus cos theta into sine theta. Okay, so from here we do have sine squared theta plus cos squared theta, then plus 1 plus 2 cos theta. Everything is over 1 plus cos theta, then sine theta. Okay? So with that, this is an identity. The square of sine squared, so the square of sine plus the square of cos with the angles being the same, that one generates a 1. So we have 1 plus 1 plus 2 cos theta over 1 plus cos theta into sine theta, which will be 1 plus 1 gives you 2 plus 2 cos theta all over 1 plus cos theta into sine theta. Now, from up there, we have some common factor. The common factor is 2. So remain with 1 plus cos theta all over 1 plus cos theta, then sine theta. I can see that one and that one cancelling out. So if those two cancel out, we end up with 2 over sine theta. We have 2 over sine theta. But, or I can put it as 2 then into 1 over sine theta. But 1 over sine theta, this one is cosec theta. So if that is cosec theta, this one will be 2 cosec theta. You end with the word as required. Or someone can put it as hence proved. Hence proved. Hence proved. Depends on which way you want to give it. I was making a review of how to apply these identities. I've said you can apply them when you are solving trig equations. It can be, for instance, it can be 5 cos theta is equal to 2 into sine squared theta minus 4. Are you seeing that? For you to solve that, you have no way out unless if you apply the one of those identities. We have 5 cos theta is equal to 2 sine squared theta minus 8. But sine squared theta is equal to 1 minus cos squared theta. So if you substitute, you'll get what you want. You'll get what you want. So we are moving forward, and our moving forward tells us that we should now talk about something else, and that is none other than we have other identities. We have some other identities. Those other identities, we can call them the addition formulae. Someone may say addition formulas because it is not one, there are many. We have what we call the addition formulae. Okay? Now, if we have sine of A plus B, these are two angles. Sine of A plus B is sine A cos B, then plus cos A sine B. If it is subtraction, we have sine of A minus B. This one is going to be sine A cos B minus cos A sine B. Now, there comes in a cos. Cos of A plus B, this one is cos A cos B minus, you have to be very keen there, sine A sine B. If it is cos of A minus B, this one is cos A cos B, then plus C. I write together, it is a plus sine A sine B. Sine A sine B. Now, there comes in the tan. If it is tan of A plus B, if it is tan of A plus B, tan of A plus B, I can take it as sine of A plus B all over cos of A plus B together. But these two, we have them, okay? those two we have them. If we expand, this is sine A cos B plus cos A sine B over this one is cos A cos B minus sine A sine B. Okay, so when you reach there, you divide through by cos A cos B. So what happens if you divide through? Let's look at what happens. If you divide through, what happens? That's what we are looking at. Now, if you divide through by cos A cos B, you do have, remember we are looking at tan of A plus B. If you divide through, up there you have sine A cos B. We are dividing by cos A cos B plus cos A sine B over cos A cos B. Now all over, now we are here, we have cos A cos B over cos A cos B, then minus sine A sine B over cos A cos B all together. So what does this one reduce up to? From here I can see we have a common cos A, sorry, cos B. So the cos B disappears. Sine A over cos A will give you a tan, so that is tan A. Then plus, here the cos A disappears, remain with sine B. Now it is sine B over cos B, which is a tan B over, from here these are the same, so they will cancel out and remain with 1 minus, from there we have tan A tan B. Okay, we have tan A tan B. Now I want you to try for me. Show, I want you to show that tan of A, now minus, we have just proved that of A plus B. How about A minus B? I want you to show me that it is equal to tan of A minus the tan of B over 1 plus the tan of A tan B. Basing on this, I want you to base on this and prove for me that one there, okay? Yes, I want you to base on that and you prove for me that one. Now, what if you have cot of A plus B? What if it is cot of A plus B? What do you have? Cot of A plus B. Cot of A plus B, this one is, cot is the reciprocal of tan. Can take it as 1 over tan A plus what? Plus B. Now, if it is the reciprocal and we have it here, I can just come and say, I take the reciprocal of what we have. So cot of A plus B, this one is giving me, what does it give me? It will give me 1 minus tan A tan B, now over tan A plus tan B plus tan B. Okay? So, let's try out something. Let's try out something in line with what we are talking about, in line with what we are talking about, in line with what we are talking about. Example, we have given that cos of A, given that cos A is equal to 3 over 5, and cos B is equal to 12 over, it is 12 over 13, 12 over 13, where A and B are acute, where A and B are acute, where A and B are acute. So I want you to find values of Roman 1 tan of A plus B, then Roman 2 cosec of A plus B, cosec of A plus what? Plus B. Let's look at the solution. Now, they have given us cos of A. Remember, they are saying A and B are acute. What that means is they lie in the first quadrant. They lie where? In the first quadrant. Remember, if they lie in the first quadrant and you have cos of A as 3 over 5, and somewhere here they are talking of a tan, that means I can draw something like that. This is my A. Now adjacent is 3. The hypotenuse is a 5. How do I get the opposite side? The opposite side, I will get it if I use Pythagoras theorem. For instance, if I call this one A, I will have A squared plus B squared giving me, okay, a C squared. So A squared plus 9 when you square 3 is equal to 25. A squared is 16 and A is 4. So if A is 4, we have a 4 there. We can get the value of tan A from here as it is opposite over adjacent. We also have cos B as 12 over 13. 12 over 13. So if it is 12 over 13, we can get the value of the opposite side. Remember, this is 12, this is 13. And if you use Pythagoras theorem, here you'll have a certain 5 somewhere. And tan of B is 5 over what? 5 over 12. So you have tan of A plus B as tan A plus tan B over 1 minus tan A tan B, which is tan A is 4 over 3 plus tan B is 5 over 12 over 1 minus, we have 4 over 3 into 5 over 12. So you can make use of your calculator and simplify that. We have some fractions there which can be simplified. In the numerator, the LCM is 12. So we have 416 plus 5, that is the numerator part, over 1 minus this with that, you have 5 over 9. Okay, so this is 21 over 12 divided by 4 over 9, or 21 over 12 times 9 over 4. If you try to simplify it, you'll get what is required. We'll link up in the next lesson. We'll link up in the next lesson.